We are studying the chapter Kinetic Theory of Gases, but this is the second step in our mission to study in gases or a study about gases in detail. In the first step, gas laws were introduced, that is Boyle's law, Charles' law, and Pressure law. Boyle's law, P proportional to 1 upon B, Charles' law, V proportional to T, then pressure law, that is P proportional to T. But while studying these three laws, you see, as in the case of Newton's laws of motion, already we have one common assumption that mass is considered constant throughout. In Newtonian mechanics, the first condition is that mass is not changeable. Similarly, here also, when you are talking about these laws, first of all, foremost condition is for the fixed quantity of the gas. That means while you are going to check the law, validity of the law, then you have to consider the quantity fixed. This is the common condition to all these. Then out of three parameters P, V and T, in all these three laws, one is going to be constant. For example, in Boyle's law, you consider T constant. You will say this is applicable for isothermal process. Then Charles' law, this is applicable when pressure is constant, means you would say that this law is applicable to isobaric process. Likewise, here also, volume constant means isochoric process. When these three laws are combined, we get the gas equation, that is PV equal to nRT. Then you also know Avogadro's hypothesis that equal volume of gases at same temperature and pressure will have equal number of molecules. Then what is the basic aim of revising all these laws at this juncture is simply that it's a very interesting. We could derive all these laws with the help of kinetic theory. That means kinetic theory is a bit advanced as well, but at the same time it is in a position to derive all the basic laws that we are already aware. Along with that, it is one way superior also that it could define the absolute zero also. Kinetic theory defines absolute zero in a very nice way, that it is the temperature at which the translational kinetic energy becomes zero. Now, another concept of mean free path. Mean free path. Free path lambda. Greek letter lambda. Molecules move random, collide between two collisions. The distance traveled is given by the term free path. But every time the collision is not going to take place after equal distances. The distances between two successive collisions are always variable. So, free paths will also be variable. If we take the average of all such free paths, then only we are going to get the term mean free path. So, never confuse free path with mean free path, like average velocity and velocity. Mean free path could be derived equal to 1 by pi root 2 d square n. Here, d is not density. Remember, d is the diameter of a molecule. It's given over here, molecular diameter. The number of molecule, this is divided by volume. That is what you call a small n. This is number density. N would be, if you consider n the total number divided by volume, then you are going to get small n. This is the number of molecule per unit volume, or you could say this is number density of molecules. You see here it's given that root 2 factor has occurred simply because the molecules are having the possibility of movement along different axes. If you place PV equal to N K T, and N is equal to PV upon KT. N is the number of molecules. If you substitute there in this relation, you find this important result that says that mean free path will always increase with the increase in temperature. Mean free path will always decrease with the increase in pressure. And when you are nearer the Earth's surface, pressure is greater. Pressure is greater, that means the mean free path is very small. And as you go on higher and higher, pressure will go on decreasing. That means there the mean free path will increase. It goes even up to the kilometers. Whereas near the Earth's surface, it is of the order of millimeter or even below that. So you have to remember, with the increase in height, lambda will increase. With the increase in temperature, lambda will increase. But at the same time, with the increase in pressure, you would say mean free path decreases.